Okay, so lecture 2.5, linear functions and models. Okay, so linear functions, linear, remember that means lines, okay? So we're going to be looking at things that have a constant slope and some models for them. Okay, so let's look at example 1. We're going to find the rate of change for the function g. So finding the rate of change, well, if this is a line, it's actually relatively simple to find the rate of change on this. What we're just going to do is find 2 points, and I'm going to find the ones that pass through the nice coordinate points. I wouldn't pick this point, for example, because I don't know if that's 1.5 or what that is. So I'm going to look for something where it crosses right on those lines. So I'll go with these 2 points. And let me identify them. This is 1, 2, and this point is 0, 2, 3. So there are 2 ways that we could find the slope here. We could use the formula m equals the change in y over the change in x. Okay, that little triangle there means the change, which is also this formula, same thing. Oops, sorry, that's supposed to be an x. We could go ahead and use that formula, plug the points in and solve, but instead I'm just going to count rise over run. So you either start from this point and you go to the other point, or you start from this point and go to the other one. So I'll start from this point. Oh, I just realized that's supposed to be a 4 there, not a 3. Good thing I noticed that. Okay, so starting from this point, how many do I have to go down? Let me get a different color here. 1, 2 down. So for my slope, we're going down 2, and then we go right 1. So positive 1. This one is weird because our changes are not consistent on this graph, so be careful when you're counting. All right, so, and we could simplify that into just negative 2. So my rate of change for this function g is negative 2. Okay, and then it wants us to express g in the form g of x equals mx plus b. So to do that, what I need is my slope, m, and my y-intercept, b. Well, I already found my slope right there, which is negative 2. And then I need to find my y-intercept. And my y-intercept is where my graph crosses the y-axis, 0, 4. So, 4. And there we go. I have expressed g in the linear form of mx plus b. Or the slope-intercept form is what it is often called. All right. Okay, not too bad. Let's move on to an application problem. Exciting. Okay, sorry, this is supposed to say example 2 on it. There's 2 examples. Okay, so the amount of copper ore produced from a copper mine in Arizona is modeled by the function. So we're given a function here, so this is nice. We don't have to create the function ourselves. Sometimes you have to create the function, which is how we were practicing writing the equation of lines. Remember when you had to find your slope and your intercepts and whatnot? So that would be an application for writing equations of lines. But here we're given the equation. Okay, and then it says where x is the number of years since 2005, and f of x is measured in thousands of tons. So we're asked to sketch a graph of f. And notice on my graph here, I am not actually given any tick marks. So it's up to me to decide how I want to graph this. So let's see. Well, normally when we graph, let's see, the number of years, we're probably going to go by ones. And then tons is a lot. So I'll go ahead and go by, let's see. Let's go with, so looking at my slope, I'm going to jump ahead here a little bit. This is the slope of my equation. So that's 37 over 1. So I'm going to go ahead and go by maybe 50s. 37 is close to 40, but I like to go with maybe 5 tens or hundreds if possible. So there's that, and then let's go 1, 2, 3, 4, and 5. So sketching a rough graph. Let's see, let's pick some values to plot this graph. Let me use some scratch work paper here. And remember, we just need 3 points to graph a line, so let's go ahead and find 3 points. So I'll pick an x value of 0, plugging that into my, let's use f of x, not y. That's going to be f of 0, which is going to equal 100 plus 37 times 0, which is just going to be 100. So let's see, this is my 50, and that was 100. So my point 0, 100 is going to be right here. Okay, that's my first point. Let's pick another point. How about 2? Okay, so f of 2 is going to equal 100 plus 37 times 2. 37 times 2, what is that going to be? 74. I'm just going to check that with my calculator since it is late and I'm known to get these wrong. Yes, it is 74. Would you look at that? So that's going to be 174. Close to 200. So let's see. Remember, this is just a sketch, not supposed to be accurate. 174. Sorry, let me replot this. 150, 200, 250, 300, 350. Okay. I said 174. So 174 is about there, maybe. And I'm going to label that 174. This is 0, 100. One more point for our line. How's about the value 3? Notice all our x values are positive because we're talking about years, and years are always going to be positive years. Well, when you're talking about producing ore. All right, 100 plus 37 times 3, and that's going to be 101, I think. I'm not certain. 37 times 3 is 111. Shucks, close. 100 plus 111, which is going to equal 211. Okay, plotting that point, 3, 211. About, is that 211? Let me check this one more time. Yep, 211. 3 and about there. Okay, and then I'll go ahead and just, whoop, there's my line, my arrowhead, and we're done. So that was a sketch of the graph. I just plotted 3 values to sketch out my graph, and we're done with that. Now, what is the slope? Well, I was being sneaky and I mentioned it before, but the slope is going to be the value by our x, okay, the 37. Because remember the slope-intercept form? It is the value by your x. That one right there. Okay, and at what rate is the amount of ore produced changing? Well, remember our slope, that's the change in y over the change in x. My y values are the thousands of tons. So let's see, we have y thousands of tons. And my x values were per years. So year. Okay, so our graph, or our slope, was 37 over 1. We can put it as over 1. So 37 is thousands of tons. Oops, tons. And we have 1 year. Okay, so the rate that the amount of ore produced is changing is 37 thousands of tons per year. And I have run out of room to write that, so I'm going to go ahead and jot that down there. 37 thousands of tons per year. Ooh, I'm running out of room everywhere. Okay. All right. Now let's see. Next one. How many tons of ore was produced in 2010? Okay, well, let's see. Tons of ore is what we're looking for. So with our function, f of x equals 1,000 plus 37x, f of x is my tons of ore. Okay, so I'm trying to find f of x. So that means I need to input an x value, and x was the number of years. So the question is, what is my input value? Well, remember, x is the number of years since 2005. And we're looking at 2010. So how many years has passed from 2005 to 2010? 5 years. Okay, so we're looking at 5 years. So plugging that in, f of 5. Okay, so we're plugging in the number of, or the years, to figure out how many tons was produced in that year. Okay, so it's going to be 100 plus, and that's going to be, ooh, my brain is tired already. Okay, 37 times 5, 185. And that's going to equal 285. So my answer is 285 tons of ore was produced. Oh, this should be thousands of tons. Was produced in 2010. And one last problem for this, and I think that is the end of this section. Last problem. At what year, okay, now we're looking at year, that's going to be our x values. At what year did the copper mine produce 285 thousands of tons? So we're trying to find the x value, and we're given the f of x value. So we know that f of x equals 285. So using our function again, except this time we're given the f of x value, which we have is 285, and we're being asked to solve for x. Okay, so let's solve for x. Let's subtract 100 from both sides. That's going to be 185 equals 37x. And I just noticed this is the exact same number as what was given above. Oh well. Okay, and so my arrow letting me know where I'm going. That's going to equal 37x. Dividing both sides by 37. And x is going to equal 5. For some reason, my problem ended up being redundant with the top one. Oh well. Okay. But if you didn't notice that, this is how you solve it. So, at what year? Well, careful, we're not going to say year 5, because remember, x stands for the number of years since 2005. So, 2005 plus 5 is going to equal 2010. So, what year did the copper mine produce 285 thousands of tons? At the year 2010, the mine produced 285,000 tons. And that is it. Okay, so that is it for 2.5. Here is your written homework. Feel free to email me if you have any questions. It's due at the end of the week.